Recording in progress.
Okay, perfect. All right, so we're starting. All right, so it's probably the first time some of you guys done math in about 3 months. I don't know. So we're gonna start by talking about interval notation. You guys should be pretty comfortable with that, right? You guys should know that if you see parentheses, that means it's not included, right? We know this. It's typically used for less than or greater than. And we'll do some examples just a little bit. Brackets means it's included. You'd use that for less than or equal to or greater than or equal to. Of course, we know what infinity means. So it means just going to the right forever, and then infinity going to the left forever. We should know those things, right? So let's take a look at example 1. Anyone want to take a stab at how example 1 should look? X is greater than -1. How would I get that started? And remember your names again?
Sure.
Kieran, yeah, go ahead, Kieran.
So you just read
Sure, right. Put a -1 somewhere. And do we include -1?
No.
Nope.
It's just
Keep it open. And then which direction do I shade? Perfect. Perfect. Good. And how come we don't include infinity? Why do I use a parenthesis, not a bracket? And remember your name again? Yeah, let me get the roster out too. I probably should do that. Let's be good for me to guess people's names. Go ahead, Sean. Yeah, well, how come I don't?
So like, it's complicated. The question is like, can you really define it? Not
Right.
You can't really
Exactly.
evaluate function and do so. You just say input other than
Right. We just don't know. Yeah, if it's some abstract idea, exactly. I have no clue. The other one should be pretty simple now. I'll do an interval notation. 7 to infinity. Sorry. So it's the other way. My apologies. Obviously, it's all real numbers. And it's a weird one. How would I not include 2? What would I say about that? Remember your name again? Yeah, go join. Yeah. Perfect. Yep. So we'll do 2, open circle. Going both ways. And how about interval notation? How would I write that? Exactly. Yeah, so when you do a union, the U stands for united or union. So you're uniting both sets. So the combination of both sets is what we want. Does anyone know what the upside down U does? I know we don't. Yeah, we don't really use it, but yeah, just seeing that's intersection. But yeah, the other ones here, the number lines, you just shade everything, right? Everything gets shaded. Here's 7, you go further to the left, that's included. So you can do a closed circle, and you go further to the left. So yeah, that's all. Yeah, this is what we use often in calculus, so just want to get used to it. Seems like you guys are comfortable with it, so good. All right, let's keep moving. Key domain, I think it's pretty obvious what that is. Let me just say text box. That's gonna be the valid x values for the function. And in the range, will be the valid y values for the function. Now let's resize that just a tad. Cool. Okay. Restrictions to look for when finding domains. There's a few restrictions. Usually, you don't want, so x cannot equal 1. You don't want 0 on the bottom, right? That's a problem, right? Can't divide by 0. Or if you have something like this here, then x has to be greater than or equal to 1, right? Because we can't square root negative numbers, otherwise it's imaginary. That's a problem. And usually when we determine domain, consider any restrictions and find them algebraically. We'll go over those techniques just a little bit. The range is a little tricky. Usually you want to look at the graph. That's probably your best bet. When you get more, when you get a deeper knowledge of these functions, then you can kind of look at the function and say, okay, I know what's the range is gonna be like. For example, square root of x minus 1, right? What's the lowest output I can get with the square root? What do you guys think? What's the lowest y value output x?
Yeah.
0, exactly. Cannot be less than 0. There's no negative out in front. So what would you say the range would be for this? 0 to infinity, 0 included, exactly. 0 is included. Graphically, hopefully you guys know how this looks. Remember, I showed you that schematic of Star Wars and the functions, right? The Star Wars is more interesting, but functions are not as interesting. But we know root x looks like this. And that's a transformation. How does that get transformed? You guys know?
One to the right.
One to the right, exactly. So the domain changes, of course. But did the range change? No. How would I want to change the range? What would I have to do with this function to get the range to change? There's a couple things I could do. Is it David?
Yeah.
Yeah, go ahead.
Add or subtract after.
Totally, 100%. There's another way to change the range too. Is it Zane? Was it
Zane.
Zane? Yeah, go ahead.
You
Zane,
can,
right. Yeah.
could you change it, like x minus 2 or change what you're doing inside the last?
Well, that would just change the left and right.
Oh, yeah,
How can I flip it?
negative.
Exactly. That's another way to change the range. 100% good. Yeah, so that's how the range could change. So yes, it's good to look at the graph, but sometimes you may not have a graph, sorry, a graphing calculator or Desmos or any computing device at your disposal. So you want to be able to visualize a graph. That's why it's very important to like see that graphical, algebraic, numerical connection, like all three of those modes, right? What's happening numerically here? We know what's happening numerically. You can't square a negative number. We know the output's positive. Algebraically, well, I mean, it's not much algebra right now, but we do know the transformations can move things left and right. And that's more graphical when you think about the transformations. But yeah, we want to be able to think that. Or here, what y value does not have? There's only one y that's completely impossible. What's that going to be? 0. How come 0 can't happen? The top is 1. Yeah, we're stuck with 1. There's nothing we can do about it. So it is what it is, right? So 0 cannot be included. So that'd be a horizontal asymptotes, right? So you guys talked about that last year, right? So, but we're gonna get to the point where we're gonna be less memorizing and more just understanding, right? That's what we want to do. I'm sure you guys focus on the understanding part, but so anyway, let's do domain. And just well, the range is gonna be hard for some of these, just so you know. I'm gonna try to do the range for some of these, but the range might be tough for some. For now, I'm just gonna focus on domain. That's all you're supposed to do for this example. So what I'll do is I'll do maybe the first I'll do the first 4 to kind of get started, and then have you guys do E through H in your table groups, and I'll walk around and help you guys out. So if we look at A here, x squared plus 2, right? I mean, it's pretty obvious. Is there any reason to be a restriction? No, exactly. So that's true for any polynomial function. And and what makes it a polynomial? What's the true hardcore definition of polynomial function? Like, what has to be true about all your terms here? The exponent has to be what? Pause, it has to be or just a whole number, exactly. If it's a negative exponent, that becomes rational, right? Or if it's a fraction exponent, it becomes a root. Then you're not going to have all real numbers. But as long as it's a polynomial, all is good. You can do whatever you want for x. However, b is a root. So what's my restriction here? Or what's the domain? Just tell me the domain. Yeah, Zay, go ahead.
Well, x is greater than -5.
Perfect, that's it. Done. I think we know what to expect here. X can't be 3. But that's not how I want you guys to write it. I want you guys to write it like this. Okay. Let's look at D. X cannot equal 4. And that's a tricky one. You don't want negatives here, right? Negatives are bad. So I need to go bigger than 1. Or can I include 1? Now, if it's on the bottom, can't include one, right? But I could. What else? So let's think about the whole story here. X definitely could be bigger or equal to 1. Or what else? Yeah, because more it could be. Could be -2. Can't be in between. In between's bad because you have a negative or anything, you have imaginary numbers, that's bad, right? So how would I write this interval notation that encapsulate all that? How would I do that? What do you guys think? So let's start with the far left. Kieran, good. Perfect. And oh, right.
When you go
1.
1 to 4,
Mm-hmm.
don't include 4.
Right. Correct. Good. Yeah, there you go. So 4 is excluded. Right. Good. Okay. So here's what I want you guys to do now. Now you guys are warmed up, right? Of course, I gave you the hard ones. Actually, before we do that, let's quickly talk about range, just for fun. Why not? I'll do range in green here. What do you guys think the range would be for this? If you imagine the graph of x squared plus 2. Yeah, because it goes up 2 and 2 to infinity. Good. So green's going to be range. I think B now we know it's from 0 to infinity. That's the lowest the square root can be. Here you can't include 0. Yeah, exactly. Let's not do D because that's a little messy. That's not your typical. Now it's a combination of functions, right? Like you got a radical and a rational. It's weird. Because it might be all real numbers, actually. I don't know. So let's find. I'm kind of curious, actually. Let's find out. But see, you can see sometimes you do need the graph. And I wouldn't ask you to do this on a test without a calculator, just so you know, for D. That's a little much. I think A, B, C is fair game. I think that I definitely think we could do. Hold on a sec. Let me go Desmos. Y equals square roots. Hold on. X squared minus 1. And divide by what again? X minus 4. Yeah. Let me clear my screen. Yeah, it looks like Y can't be 0. Okay. Well, no, it could be 0. No, it could be 0. Sorry, it can't be probably between. Ooh, 1, yes. You know, now I know why. It's M behavior. It can't be between either. Yeah, it's interesting. Yeah, it looks like it's going to be from negative infinity to 0 included, and then 1 not included to infinity. And the reason why, this is much later. We won't get to this till spring, but it's called M behavior model. What happens if you square root x squared?
Yeah.
You get pretty much get x, right? But technically, it's actually the opposite way. So when you do M behavior models, you look at what Y does, X is really watch. Again, I'm kind of like, this is like 7-8 months from now, like we start moving on to calculus. But yeah, what's going to happen is that that's kind of like X. And so you do X over X, which is essentially 1, but you can't get it exactly. So it gets really close to it, because when you try to imagine what does Y do when X gets really big. So you have to think that way, but we're not there yet. We're not going to get there for a while. So let's not worry about it for now. All right, here's what I like you guys to do. Try E, F, G, H, just domain. Don't worry about range, just domain. I'm going to pause my screen and just do it. And then we'll compare in a few minutes and talk to each other, help each other. Once I get done, I'll walk around and see if you guys are on the right track. You may have to do sign charts, by the way. Maybe remember that. I don't know. Yeah, I say the tough one for you guys to do in groups.
It's like, it goes through. It's excluding 1, 2. It's a raise 5, and then we jump all this. Everything on one three works.
Use a doozy, just so you know.
It can't be anything in between.
So you do a number one. Actually,
Bracket.
I'll talk about, but after you factor it, what you do is, you see what makes each of these zero. And then you test each interval out. You want a positive interval. I'm gonna talk more about that.
Well, yeah, it's like.
Totally not. How are we doing here?
Six is not.
You include 6.
No, there's a, it's not.
No, wait, isn't Yeah.
What are you guys doing?
Yeah, that would make root 0, but there's a negative. Oh, yeah.
Because.
That's why I couldn't.
Yeah, stacked it and then gap it together.
That should be an easy one.
And then plug it in.
Oh wait, I messed up F, guys. I messed up F. Guys, do you guys see the mistake I made for F? Yeah, okay, of course 7 can't be included. I know that. But I can't plug in numbers, well, so, okay, of course, I also can't plug less than -2, right? So that was really dumb of me to just put that as the answer. I rushed out. I was so excited to do G and H, maybe. I don't know what it was. X less than or equal to sorry, X has to be greater than or equal to -2. Yeah, my bad for F. H, I'm pretty sure I got. For h, you can't divide by 0, so 8 has to be excluded. But it's gotta be less than or equal to 12.
So negative 80 less than
You skip over 8, right?
yeah.
G is a fun one. You can't have 5 or -5. This makes the bombs out 0.
Yeah. But then there's the two negative.
You can have that.
Right, so what's gonna happen is that, yeah, 5 -5 do happen to, so let's talk about sign charts. I don't know, did you guys do sign charts and underline analysis and class? Yes, no, I'm hearing, okay, I should check, but here's what you wanna do. So whenever you have a non-linear, expression underneath the radical, underneath the square roots, because the cube root can cube root whatever. So underneath the even root, there we go, I'll be even that more for that. Under an even root, function, you have to guarantee that stays positive or 0, that's fine. But the expression will be greater than or equal to 0. So you factor it. After you factor, you find what I call the critical points, which make the 0. That's 0 and 6, right? So okay, 0 and 6. So clearly, anything bigger than 6, like 7, for example, 8, for example, makes each of these factors positive. A positive times a positive is a positive, right? So that's cool. But between 0 and 6, that's an issue. Like, we have to choose 1. That's positive, that's negative. What happens when we multiply positive by a negative? Yeah, and that's not gonna be okay, right? Because that'll be imaginary, right? That's a problem. So we're gonna exclude that. And of course, anything less than 0 is cool because that's a negative, 2 negatives multiplied is still a positive. So we gotta be less than or equal to 0, greater than or equal to 6. There you go. And 0 and 6 could be included because who cares? It's not a fraction, right? That's fine. We do the same thing for G. We see another non-linear expression underneath the square roots. So I factor that, which is easy. Factorings, by now you guys should be full factor, right? Now here, x minus 1 times x minus 3. Now, if you think about it, if x is bigger than 3, that expression stays positive. If it's less than 1, that expression is still positive, which means not okay. Like if I put in 2, of 1 times -1 is not okay. Or 4 minus 8 plus 3, that's -1, not okay. So anything less than or equal to 1 or greater than or equal to 3. However, -5 have to be skipped to make those 0. So you have to make sure you skip them along the way. So you actually have to write 4 separate intervals. Kind of crazy, right? So that's called a sign chart or a number line analysis. Pretty simple. Whenever it's not linear and you do some factoring, do it. We'll see this often throughout the year. And it's actually, when you move on to AP Calculus, you do sign charts up the wazoo, like just all like daily, you're doing sign charts. So we just want to get in the habit of that. So again, the sign chart, all it ever is just a number line, but when you have something non-linear and you have to see what makes a positive or negative, we care about that. That'll make sense. We can move on to calculus, why we care about that. But for now, yeah, we want to square root positive or 0, not negatives. And of course, H is just that. So any questions? Good. All right. Let's keep moving. All right. So, and our goal today is to get to end of page 4. So that's our goal today, to get to end of page 4. I think that's what the notes I made to myself. Yep, end of page 4. Okay. And then the hope is to give you guys a chance to do some homework today. So that this way you have no homework for math over the weekend. All right, C is pretty easy. I really don't think I have to be around the bush here. Like, hey, you're adding 2 functions, just add them. It's a fact. Multiply, divide. Of course, divide makes sure the volume's not 0. So yeah, and then we'll find domain for those combinations. It's just that simple, right? So let's take a look at example 3. Let's get a domain for each of those. That's pretty obvious. 0 to infinity. And in negative infinity to 4. That's all. Right? Squared away with that one. Here you asked to find the combination, evaluate, and also state the domain as well. So that's just root x times root 4 minus x. That's root x over root 4 minus x. That's reversed. And that's root 3 plus root 1, or 1 plus root 3. That's going to be 0 over root 4, which is a 0 anyway. And that's going to be root 2 over root 2, just 1. But let's do domain next. I'll do in green. Okay, but question so far?
Have used stuff out of the way, just add the two functions. You can't combine them, but just they are, they are. By the way, rationalization, I'll tell you if I want to rationalize. I didn't care to ask for that, so don't worry about it. So, sometimes it's good to do. I don't think it was really necessary. It's just, I think actually it's more work that's not needed, and I mean, it might make it look uglier. I'll tell you when I want you to rationalize something. So it's fine to have radicals at the bottom, unless I say it's not fine. There you go.
What you got one for?
I might have made a mistake. Hold on, did I make a mistake? If I plug in 2, so that comes root 2, root 2, root 2, root 2 should be 1. Unless I made a mistake, I don't know. Did I make an error? Is that right?
Oh, no,
Okay.
no, F is 1.
Oh,
I
F.
don't think it's right.
If I plug 0 in, that's 0 over root 4, 0 over 2 is 0.
Oh, you plugged 0.
Yeah.
Okay.
Okay. No, I'm make mistakes, guys. I'm totally human, so let me know. Okay, domain. X has to be greater than or equal to 0 here. And X has to be less than or equal to 4. So you really want to be as restrictive as possible. So it's gonna be between 0 and 4. Because you have to make both happy. Right? Almost the same thing here, but you can't include the 4. Right? And almost the same thing here, but you can't include the 0. So we gotta be as restrictive as possible. Very important. Okay. We're good? All right, we're almost done. And I knew that page was gonna be an easy one. Okay, composition of functions. That's the last thing we're gonna talk about. And we'll do some stuff down below. So this symbol, it's kind of a funny symbol. It's not times. If it's still, then that's times, by the way. Or times we just put F and G next to the other. That means composition. And whatever is to the right, which you plug it to the left. That's F of G. If I reverse it, it would be G of F. Then F would go inside G. So you see the examples here, right? So you're asked to find the following safety domain. So that's what that means. Okay, so F open circle G means you're doing F of G, G of X, and then the domain of F. And when you do find the domain, you have to kind of consider the inside first, and then after you plug it in. So for A, if I were to work that out, that would be F of G of X. So I got to replace the X and e to the X with root X. Or here, G of F is going to be this. So it's pretty clear X has to be greater than or equal to 0. So that's my domain. Here, what do you guys think would be my domain for B? I do a radical. What do you guys think? Can e to the X or be a negative number?
No.
Why not? Good, that's right.
It's you can't like.
Right, unless you do a transformation, then no, you have
Right,
front.
but the parent function is.
And E roughly is 2.718. It's called Euler's number. So yeah, e to the X, and graphically also understand what's happening graphically, right? That's e to the X. That never has a negative output. So you're never square rooting a negative. So all's good. All's good. So that'd be all real numbers, right? All right. So let's do some more practice on your own. Go and try example 6. You have a combination of functions here. I'll pause the screen and work these out and share with you guys in a moment. Then we'll do example 7, and then we'll work on homework. And we got what time today? 9:45 or 9:40? 40. Okay. So yeah, so totally good. We will have some time to hopefully get the homework done in class. I'll walk around and say, you guys are doing.
So you gotta do some factoring for B, yeah, and even C as well. That's it, quite sure, factoring, I kind of just did it. So, once you get the hang of it, you kind of just know what to do. Hopefully the combination is fine, that's not a challenge. Well, what's the question? The question, no? So, yeah, so for A, remember you have 1 over x plus 4 over root x, I don't care if rational is on there, but you gotta be as restricted as possible, x can't be 0, but also can't be negative. If it goes 0, it's gonna be non-inclusive. For B, factor that, right? If you factor that,
That's x plus 1 times x plus 3. We know this now. So your critical points, or what makes it 0 is -1 and -3. But you gotta go less than -3 or greater than -1. Not inclusive because you can't divide by 0 either. And don't go in between because that's gonna be bad. Because you'll be square rooting a negative number. For C, same thing, don't go in between. That's x minus 2, x plus 2. So you can't go less than -2 or greater than 2. Or I'll just do like that. So this goes with this and this goes with this. That makes more sense. But yeah. And again, you can't include them. So your homework will include some of these things. And then lastly, for example, 7. Now, kind of laugh. If you really want to be a smart ass about example 7, you could do this. You could say, so here's the h of x is a composition, right? So you got to figure out what f and g are. You could say f of x equals x. Don't do this because I'll actually get a little annoyed if you do this. You totally could do that, right? Because that is true.
if f of x is x, just plug this into that, and there you go, you get that. I want to get a little more creative.
So don't do that. Or you could have just reversed it, made that G, made that F. You could have done that too. That would have been fine, but don't do that, please. Instead, I would suggest you guys do something like this here. Maybe let f(x) be 1 root x and g of x be x cubed plus 1.
So that way you're kind of thinking more of composition, right? Like, okay, if g of x is inside, then the whole thing is 1 root x.
And we need to be very comfortable with composition functions as we move towards calculus in the spring. There's going to be a moment we have to kind of really know our compositions really well. Okay, I think that's a good stopping point. I don't want to drone on for another hour, an hour of lecture I think would drive you guys nuts, right? So homework will be this here. So you guys have the homework packet. I am going to print the solution key for you guys so you guys have it, just so you don't have to feel the need to use your devices, so you can check your work. So it's going to be the first 2 pages, pages 1 and 2. It says homework 1 and 2. So it says homework number 1. You can do 1 through 10 all. So 1 and 2 are pretty straightforward, finding intercepts or finding solutions or testing solutions out, writing equation lines, determine whether something is a function. I know I didn't talk about that. Plug into functions, find the zeros. I know we didn't talk about transformations, but just do it anyway. I know we didn't talk about piecewise, just do it anyway. Then you got 10 here. So some of it's kind of correlating to the summer assignment. 11 and 12. Actually, we could do 11 and 12. I don't know why I left those out. That's weird. Well, 12, not really, but anyway. 13. That's a relation. 14. Combination function, okay, domain, that's good. 15 to 20, now we're talking, right? That's exactly what we've been doing today. 21, don't worry about. Yeah, I don't know why I didn't do why I didn't sign 11. That's okay. That's fine. So that's the homework. I think you guys could get this knocked out before class is over and have no homework over the weekend for this class. So that'd be nice. Say go ahead. Yeah, you could do it on this. So yeah, let me talk about homework. I wasn't very clear about it. So yeah, if you have like a piece of paper or like a notebook, that's really cool. Or if you do it on the worksheet itself, there's no space, you could do that too. What I do ask is that when you finish the homework, you take a picture and upload to Schoology. Of course, you can have your phones out. So just do it over the weekend or later today. That's fine. But definitely, I will ask you guys to upload the homework. What I'll do is I'll put let me assign the homework in Schoology. Let me actually create a homework assignment and put the instructions. Once I have that, I'll post it, I'll project it, so you guys know what the expectation. The expectation again is to upload it as a PDF, just a single file. That's how I collect homework. So I don't actually physically collect it. If I do, it just gets messy and I may not give it back to you for a long time. So I much prefer you upload it and I just correct it that way. And by the way, I don't judge homework on accuracy. Just get it done. If you make mistakes, all good. I'll give you full credit. We will have a homework quiz on this the next time we meet. We'll start doing homework quizzes next week because next week's our first full week, right? And that we'll get in that rhythm of doing homework quizzes. Anyway, and as you imagine, it's going to be probably on domain, right? That's the key thing we did today. All right, let me go and stop the recording.